See this question from the transaction concurrency control. T1 and T2 two transactions given, and Ri of V means denotes that read of the data by transaction Ti variable V. Okay, Wi of V denotes the write of the data V by the transaction Ti. Okay, so the question is the total number of conflict serializable schedules, okay, that can be formed by T1 and T2. So total possible conflict serializable schedules. So total number of concurrent schedules are, okay, something like, so 4 instructions and 4 instructions, total 8C4, total number of concurrent schedules. 8C4 is the total number of concurrent schedules. Okay, total concurrent schedules, 8 factorial divided by 4 factorial multiplied with 4 factorial is total concurrent schedules. But here we need to calculate total number of conflict equal serial schedules. Okay, so here the total possibility of conflict equal serial schedules can be, okay, split into 2 parts. One part, number of serial schedules conflict equal to T1 followed by T2, number of concurrent schedules, not only serial, okay, number of concurrent schedules, conflict equal to T1 followed by T2 serial is one part of the problem. Number of concurrent executions which are conflict equal to T1 followed by T2, and second part of the problem, number of concurrent schedules which are equal to T2 followed by T1. Number of concurrent schedules which are equal to T2 followed by T1. T2 followed by T1 serial schedule. So if you observe this one, this last operation of the T1 and this first operation of the T2 is conflict pair. Because of that, only T1 followed by T2 serial can be conflict equal to the T1 T2 serial. Okay, so that means this T1 is one transaction, T2 is other transaction. Okay, so we want concurrent execution equal to T1 T2 serial. R1X W1X R1Y W1Y, okay, is the T1 operation. R1X W1X, okay, R1Y and W1Y is the T1 operation, and T2 operation R2Y and W2Y, R2Z and W2Z, R2Y and W2Y, R2Z and W2Z. So here we need to calculate the number of schedules conflict equal to this serial. This is T1 T2 serial. Okay, so number of schedules conflict equal to this serial. So see here now, so last operation of T1 and this first operation of T2 itself is conflict pair. Because of that, no other concurrent execution conflict equal to this serial. So the one part of the question is, okay, one serial schedule only, okay, is conflict equal to the given schedule. Conflict equal to T1 followed by T2 serial. So only one serial schedule among these concurrent schedules conflict equal to T1 T2 serial. Now we need to compute the number of serial schedules which are equal to T2 followed by T1 serial. Number of serial schedules which are equal to T2 followed by T1 serial. So if you write this schedule T2 followed by T1 order, okay, so we are expecting the concurrent execution should be equal to T2 followed by T1. we need to calculate number of schedules which are equal to T2 followed by T1 serial. To get the schedules which are equal, conflict equal, okay, to get the schedules which are conflict equal to T2 followed by T1 serial, take the last possible T2 and first possible T1 which is conflict. This R1X and W2X not conflict with anyone, R1X and W2X not conflict with anyone, and this is the last possible, okay, this pair is conflict pair. This pair is the conflict pair. So this W1X means we'll be writing these combinations. Okay, so we can take W2Y must before the R1X, R1Y. So W2Y before the R1Y means this further operation should be in the same order and this previous operation should be in the same order. That means there is no other choice for R2Y. R2Y should be placed here only, and W1Y also should be placed here only. Okay, so these four operations is going to be the same sequence, okay, for every concurrent execution which is conflict equal. Okay, the remaining operation can be interleaved. Remaining operations can be interleaved. Let us see how many different other interleavings are possible. Okay, so now, so these two operations not conflict with these four operations. These two operations not conflict with these four operations, but these two operations should be after this W2Y only. Okay, these two operations should be after this W2Y only, and so, and these two operations, okay, also not conflict with these four operations, but these two operations should be before this R1Y and W1Y only. Okay, let's place one set first before placing the second set. Okay, if I take this R1X and W1X, these two operations can interleave with these two operations because operations of the same transaction must execute in same order. Okay, so this R2Y and W2Y can interleaved by R1X, W1X, R1X and W1X. These two pairs can be interleaved, and these R1X and W1X should be before this, and these two are also should be before this because this conflict pair should be maintained. Okay, same precedence. Okay, this 2 and this 2, okay, 2C2, that means total 4, 2 plus 2, 4 operations. Out of 4 operations, the interleaving 2 operations and 2 operations interleaving, 4C2, total 6 ways is possible interleaving for these two. These two can be interleaved 6 ways. Okay, and 2 more operations are there which is not mutually independent. Okay, because these two operations depending on after W2, R2Y and W2Y. So because of that we can't directly multiply the permutation. We need to expand it. Write all possible 6 combinations. Okay, so that means R2Y followed by W2Y. Okay, followed by R1X, W1X and R1Y, W1Y. Okay, so then other possibility R2X, this R1X is interleaved. R1X is interleaved, then followed by W2Y and W1X and R1Y and W1Y. Then other possibility of interleaving for these interleavings I am writing. Okay, total 6 interleavings. Okay, last 2 operations as it is. Okay, so then this R2Y, R1X, W1X. Okay, these two is before this W2Y. Okay, so after that W2Y, and followed by these 2 are as it is, R1Y and W1Y. So next, so let's take the R1 or T1 operations first. T1, these 2 operations, R1X and W1X. R1X and W1X. W1X followed by R2Y and W2Y, and this interleaving is as it is, R1Y and W1Y. Then so R1X, R2Y is interleaved, then W1X and W2Y, and these two are as it is, R1Y and W1Y. Then R1X, okay, so R2Y and W2Y, and then W1X. Okay, so right, so these two operations in between, R1Y and W1Y. So these are the 6 possibilities after placing these two operations. After placing these two operations, total 6 possibilities we got. Okay, then finally we need to place these two operations also. So fortunately there is no conflict pair for these operations with this one. Conflict pairs are not forming. Only restriction, these two operations should execute after W2Y. These two operations should be followed after W2Y. Okay, so that means that the total possible 2 operations here and 1, 2 after W2Y means here this interleaving is done. Okay, 1, 2, 3, 4, these 4 operations, and with these 2 operations, that is R2Z as well as, okay, W2Z can be interleaved. Okay, 4 plus 2, 6C4. So this is 6C4 interleavings. Okay, 6C4 interleavings means 15 interleavings here. Okay, then in the second schedule, so W2Y is here. After W2Y, these 3 operations and these 2 operations can be interleaved. Okay, these 3 operations and these 2 operations can be interleaved. 2 plus 3, okay, it is become 5C4. 5C3. So 5C3 is 10, right? So 10 different schedules. Then if you take this third one, these 2 operations only, because of W2Y in the 4th position. After that 2 operations and these 2 operations, 2 plus 2, 4C2. 4C2 interleaves. Okay, that means 6 possibilities. So here also 6 possibilities. Okay, here also 4C2 interleavings. Okay, 6 possibilities. Okay, and here also 6 possibilities. Okay, 4C2 interleavings, 6 possibilities. Okay, then here again, okay, these 3 operations can be interleaved because the W2Y in the 3rd position, it should be execute after W2Y. So these 3 operations, these last 3 operations and these 2 operations can be interleaved. Okay, 3 plus 2, 5, 5C2. Okay, 5C2 or you can say 5C3. Okay, both are same. So then 10 operations. Okay, so these are the total number of concurrent schedules which are conflict equal to T2 T1 serial. These are the total number of concurrent schedules which are conflict equal to T2 T1 serial. Okay, so that means, so 18, 28, 38 plus 48 and, okay, so 53, 48 plus 5, 53. 53 schedules, concurrent schedules which are conflict equal to this T2 T1 serial. One serial conflict equal to T1 T2 serial. Then total number of schedules means this T1 followed by T2 concurrent execution equal to this T1 T2 serial and concurrent execution equal to T2 T1 serial. This 53 and this plus 1. Okay, total 54 schedules. Total 54 schedules which are conflict equal to the given schedule. So the answer to this question is 54. Out of all concurrent schedules, 54 concurrent schedules conflict equal to the T1 T2 serial. right? So in this question, it is not just about the number of concurrent schedules, okay? So here, out of all the concurrent schedule, how many concurrent schedules are conflict equal to serial schedule? So concurrent execution conflict equal to serial, okay, which is T1 followed by T2 serial is only one possibility, but the concurrent execution conflict equal to T2 followed by T1 is 53 possibilities. Total answer to this question is 54, right? See this question, consider a relation, consider the relation customer and balance. Customer is the primary key, and there is no null values. We would like to rank customers according to decreasing balance. The customer with the largest balance rank 1, ties are not broken and ranks are skipped. If exactly 2 customers have the largest balance, they each get rank 1 and rank 2 is not assigned, okay? So he wanted to apply the ranks, okay? So we would like to rank the customers. Okay, so first of all, try to see what is mean by the ranking. So in case these are the given customers and their balances, okay, these are the given customers and their balances. This attribute customer, I'm just written like a customer ID, okay, so then balance, okay. So let's say various customers are there, C1, C2, C3, C4, C5 and so on, and their balances need not be in one sequence order, okay, but just I'm writing, okay, so 80 balance, 60 balance and 60 balance, and so 50 balance, assume in terms of, okay, so the thousands or whatever it may be the so unit, okay. So now we would like to rank the customers. This is the account relation, we would like to rank the customer with the highest balance should get rank 1. So this is the expected ranking, okay. So what is expected ranking? Rank to this given customers. The expected ranking is of each customer should be like this, okay. Customer with the highest rating should get the rank 1. Because 2 people got the rank 1, rank 2 not assigned. The next highest customer is become rank 3. Because 2 people got the same rank, rank 4 not assigned. The next customer should get the rank 5. Okay. This is the expected ranking. Okay. This is the ranking we wanted to assign to the customers by using SQL query. Okay. Now, for this, he gave 2 queries. Query 1 is given and query 2 is given, and 2 queries is given for assigning the ranks. Consider the following statements, okay, and he gave some 5 statements, and out of that which statements is true about those queries, okay. So first statement, query 1, query 2 produces same row set for some but not all databases. Both query 1 and query 2 correct implementation, okay, for the specification. Query 1 correct implementation but not query 2. Neither query 1 nor query 2 correct implementation, and assigning rank pure relational query takes less time than scanning in decreasing balance order and assigning ranks using ODBC. Okay, then what are the statements are true? It's a GATE 2016 question, right? So it is little lengthy question. So let's see this one. See, while we are trying to trace the SQL query, always keep in mind, okay, visualize the query with respect to flow of the execution. Okay, so in this query, select clause is there, from clause is there, okay, where clause is there, okay, select clause is given and from clause is given and where clause is given, as well as group by clause is given. Okay, so the execution of the query starts from the from clause. Execution of the query starts from the from clause. Let's say 2 account relations are given, from clause is executes first. Okay, 2 account relation, okay, this account relation A and account relation B, okay, so cross product, from clause will do the cross product. Okay, from clause will do the cross product. Okay, so that means no need to write the total result of cross product, but just for explanation purpose. Okay, So this is one table and this is other table. First from class perform the cross product. From class, this A table of the account renames to A and this is renames to B. It is done cross product. So after from class, then where class executes. Okay, after from class, where class executes. Okay, what is where class condition given? Where class condition given, A balance less than equal to B balance is the where class condition. So that means this balance is less than equal to this balance. Okay. So if you observe this, where class condition, the 80 less than equal to 80, two records true for the C1. For the second record, two records true for the second record. Okay. This 60 less than equal to 4 records. This 4 records, okay, so balance is less than equal to 60. Similarly, for this 60 also, 4 records balance less than equal to this 60. Okay, and this C5, okay, this 50 less than equal to all 5 records. All 5 records less than equal to this 50. That means in the cross product total 25 records, 5 multiplied with 5, 25 records of the cross product. 25 records of the cross product after applying where condition. Okay, so 2 plus 2 plus this 4 plus 4 plus this 5, these records in the result of where class. Okay, after this where class condition, then group by class executes. Then he groups based on A dot customer ID. Okay, then see this one, then he groups based on A dot customer ID. Okay, so if it is group the based on this A dot customer ID, this is used for group by. Okay, it will execute after this where class. So the number of groups which are satisfied for number of groups. Okay, C1 records of one group, C2 records of one group, A dot customer ID C1 one group, A dot customer ID C2 one group, A dot customer ID C3, C4, C5 is the total 5 groups. Okay, so after group by class, then finally we are retrieving the selection. Because having class, those things are not used in the query. Then next it is going to be execute the select class. So what is select class is applied for this one, A dot customer ID count of B dot customer ID. Okay, so then the after the selection this A dot customer ID group by attribute and number of records of the group. Okay, so that means so A dot customer is one attribute in the selection and count of records of the group. Count of B dot customer, okay, is another attribute. Okay, these are the two attributes in the result of the selection after group by class. These are the two attributes in the result of the selection after group by class, right? Okay, now see this one. So this C180, okay, C280, 2 records with A dot customer ID is C1, 2 records A dot customer ID is C2, 2 records A dot 4 records A dot customer ID C3 and 4 records and 5 records. Okay, that means first group count is 2 records, second group count is also 2 records, third group count is total 4 records, and fourth group count is okay is also 4 records. Okay, and fifth group count is total it is 5 records. See, instead of assigning rank 1, rank 2 and skip the rank 3, okay, and instead of assigning rank 3 to the C3 and C4 and skip the rank 4, here assign rank 2 and skip rank 1, assign rank 4 and skip the rank 3. So the final conclusion, the query 1 not correct, this query 1 result, okay, is not correct for okay given ranking specification, because we would like to rank like this. Okay, so this is the expected ranking. Okay, so this is the expected ranking. So we want to rank the customers like this, okay. So 1, 1, 3, 5, 3, 3, 5, but the query 1 ranking like this, okay. So what we can conclude that the query 1 incorrect, query 1 incorrect for, okay, ranking. Result of query 1 not correct for the ranking, okay. Now, so now let us see what about the query 2, query 2 correct or wrong, okay. This is the first query explanation, okay. Then one more query is given for the ranking purpose. Let us see this query 2, okay. Again, see the flow of this query, okay, query 2 flow. So the from class, okay, cross product of two account A, account B, then where class tested this balance condition less than condition, and then group by based on the customer, and then selection is A dot customer ID 1 plus count of B dot customer ID, okay. A dot customer 1 plus count is done in the selection, okay. And here instead of less than equal, it is only less than, okay. So cross product is done, then A dot balance less than B dot balance condition over the cross product, then group by based on A dot customer ID, and then apply the selection, okay. So now if you take the query 2, okay, again 2 tables cross product is used by the from class, okay. So 2 table cross product is used by the from class executes first. From class cross product these 2 tables, this is A and this is B, okay, 2 instances of the account relation. Then after that where class, according to the query 2, the where class condition is this A dot balance only less than condition, okay. In this way 80 not less than anyone, this 80 not less than anyone, okay. So this C1 C2 completely not in the result, okay, because this 80 not less than any of these, and this 60 less than these 2 records, and this 60 also less than these 2 records, and this 50 less than these 4 records, okay. So this C2 2 records, C3 2 records, C4 2 records, and the C5 4 records. That means after the where class condition, this is the expected data, so customer ID and balance, and customer ID and balance, okay, 4 attributes in the cross product. That means C1 C2 completely not in the result, okay. So C3 his balance is 60 and C1 balance is 80, okay. C3 his balance is, okay, 60, one more record, C1 whose balance is 80, okay. Similarly C4 balance is 60 and C1 balance is 80, and C4 balance is 60 and C1 balance is 80, okay. These are 2 records, these 2 records, 4 more records, okay. C5 balance is 50, satisfied condition with 4 records, okay. That means C1 80 also, okay. So this is C2, the second record, and the second record is C2, C2 80 and C2 80. So C1 80 and C3 60 and C4, okay, 60. These are all C5 50, okay. This is also C5 50 and this is also C5 50, okay, 4 records. Now this is the result after where class. After this where class, then group by based on A dot customer ID. If you do the grouping based on this A dot customer ID, C3 group 2 records, C4 group 2 records, C5 group 2 records, okay. So after that selection executes, okay. This is the flow, select class, okay. So the end result is becomes, the result of the query is become something like this, okay. So the output of the query is become like this. So A dot customer ID A dot customer ID and count of B dot customer ID plus 1. Okay, count of B dot customer ID plus 1. Okay, now that means C3 is the first group, count is 2, 2 plus 1 is 3. C4 is the second group, okay, count is 2 records, 2 plus 1 is 3. And C5 is the third group, okay, so count is 4, okay, 4 plus 1 is 5. This is the result. So if you observe this query giving correct result for C3, C4, C5, okay, C3, C4, C5, okay, these records getting correct result, correct ranking only. Okay, C3, C4, C5 getting correct result only, but the problem is the highest balance customer, rank 1 balance customer not in the result. Okay, so because of less than condition, this C1 data is eliminated by the time of grouping. By the time of grouping, A dot customer ID C1 is not at all there. That means first rank customer excluded in this result. Okay, so the drawback of the query 2, okay, so the remaining first rank customer always not in the result. First rank customer not in result. This is the drawback of the second query. Means overall second query also incorrect only, because we wanted to rank all the customers. Okay, it will give correct ranking excluding the first rank. First rank is not in the result completely. So overall we can say it is also incorrect for ranking. Incorrect for the ranking. Okay, second query is also not correct for the ranking, right? The reason is, okay, so first rank customer is always fails. Okay, now let us analyze one thing. So first query is going to be fail whenever any customer having two same balances. Okay, so two customers with the same balance, for those customers will get the wrong answer here. Okay, but if that balance with only one customer, say only one customer is balance is 50, that rank is correct only. The second query, whatever result is given, it is correct only, but the first rank customer not in the result. Okay, either one customer or more than one customer who have the first rank, okay, highest balance is not in the result. In this way both are incorrect. But there is a particular database, okay, some records of first query, some records of second query can be same. For example, some other than the first rank, 10 customers having distinct balance, okay, other than the first rank. Okay, those 10 customers having distinct balance also in the same result in the second query. Few records can be same, but not all records, right? Now read the statements. What are the different statements is correct for this given question? Okay, query 1 produce same row set as query 2 for some but not all databases. Okay, for some records it can be same. Okay, for some records it can be same. Okay, for some records query 1 and query 2 can produce, okay, some records of the query 1 result, some records of the query 2 result can be same. So in what way it is same? For example, if one more customer with the balance 60, balance 40, okay, then only one customer balance 40. That means C5 is also 5 rank, C6 is also 6 rank in both the queries. Okay, so except the first rank, those who have distinct balances will get the correct answer. Okay, then the second query, both query 1 and query 2 correct implementation for given specification is wrong. Okay, both are false, both are incorrect. Query 1 correct but not query 2 is also wrong. Neither query 1 nor query 2 is correct assignment is correct. Okay, both are wrong queries. Assign rank with pure relational query takes less time than scanning in decreasing balance order using ODBC. ODBC means Open Database Connectivity. It is driver, okay. So from the C++ languages, if you want to C++ program, if you want to access data from database, we should use the driver ODBC. For Java language, we use the JDBC. Okay, so ODBC is Open Database Connectivity, is a driver which is used to access data from high level language to database. Okay, from RDBMS data we can access but to the high level language. What he is saying that assign ranks using pure relational query instead of writing pure relational query to assign the ranks. Okay, so scan the data decreasing order. Okay, it means simply access the data decreasing order. Okay, like assume that, okay, select a dot customer ID, select customer information, select customer information. Okay, and balance is retrieved from the database file. Okay, from account relation, and decreasing order we retrieved order by balance. Okay, let's say decreasing order. Okay, like this data is retrieved from database. Okay, from database. Okay, so by using ODBC, by using ODBC, okay, retrieved this result set to one C program, assume that. Okay, C program result set. Okay, and assign ranks by using C logic. Okay, assign rank. Okay, using the C language based on this decreasing, not the query. So if you do like this, so decreasing order of the balance data is retrieved, decreasing order of the balance data is retrieved. That means this access cost, this decreasing cost, the cost of this decreasing is takes sorting algorithm required. It required order of n log n time. Once you get the data in decreasing order, assign ranks in high level language can be done in order of n time for n customers. Then overall time complexity, if you go for this second way, scan decreasing order and assign ranks using ODBC, if you do like this, then time complexity is become n log n. Okay, if you write the pure SQL, pure relational query, not the functionality of the SQL, okay, pure relational query like a cross product selection and all, okay, so which involve the cross product, n records and n record. Cross product is done over the n square records of the cross product, applying the where conditions or something. This pure relational query to assign the ranks, is takes cross product and selection, means it takes n square time. It means that the ODB decreasing order, if you retrieve decreasing order balance and assign the rank by using C logic, takes less time than the pure relational query. But what he is saying that assign ranks with pure relational query takes the less time. Okay, is also false statement. Okay, so that means the correct statement to this given question is 1 and 4, right?